All right, we're going to be practicing identifying domain and range with graphs. The first thing it says we need to do is determine whether each graph represents a continuous or a discrete relationship. And then we need to state the domain and the range for each. Well, first of all, to be continuous means there's no breaks in the graph. That means the graph keeps going. There's something at every point of value. A discrete relationship means that there's breaks in the graph, or jumps in the graph, or holes in the graph. So that's really what we're looking for. So let's start with this first one. Let's look at it together. This graph starts at a solid point, and it goes, and it goes, and it goes, and it goes. Did you see any breaks in this graph? Yeah, I didn't either. That means this one's continuous. Now, domain and range. The domain is describing where the x values live. So in other words, I need to know how far to the left and how far to the right this graph exists. So the leftmost point is right here, and if I follow that down, this goes -10, -8, -6. That red line I drew fell in between the -8 and -6. That value is, of course, -7. Now let's come over here and see how far to the right my graph goes. It's on this line. That's an 8, that's a 10, right in between it. That means it goes to 9. So for my domain, depending on the notation that my teacher wants me to use, I know for my domain I include -7, and it goes up to +9. And when I include the values, I can use the square brackets. My teacher might also have said that they want me to write this as an inequality. -7 is my smallest value. It is less than or equal to x, which is less than or equal to 9. And again, I have the equals to because it actually goes up to and includes those values. Now we need to think about the range. The range is the y values, so I need to know how far down and how far up my graph goes. My lowest point on my graph is right here. And again, if I look at these numbers, that's a -4, that's a -6. Who lives right in between? -5. Now I need to find the highest point for my graph. This happens to be the highest point on my graph. I'm going to follow it across. This number's at 6. This number's at 8. What lives right in between it is 7. So again, if I want to use interval notation, I can say that my range is from -5 to +7. If my teacher wants me to write it with inequalities, I will write that -5 is less than or equal to, now remember the range is representing the y values, so y, which is less than or equal to 7. And I have now found my domain and range. Let's look at problem C together. Look at this graph. That's a solid point. The line is solid, but look right here at this particular point. That's what we call a hole. Because there's a hole, is this continuous or is this discrete? Well, it's starting at a hole. That means it goes up to but does not include that point. We're going to need to really look at our definition of continuous or discrete and see which one our instructor says it should be. Let's stop for a minute and look at our domain and range. This might help us out. So domain again is my x values. If I look, this goes 4, this goes 8, right in between it, that must be 6. How far over does it go? It goes to this point, right in between 36 and 40, that must be 38. Now if I'm going to use interval notation, this time I'm going to start with a parenthesis because I go down to 6, but I can't actually get there. That's when I use a set of parentheses. It goes up to the value of 38, and it includes the 38, so again I get the square bracket. As an inequality, that means 6 is only less than x, which is less than or equal to 38. Now, let's look at our y values. The lowest y value is this point right here. I follow it across, that hits right at 4. Let's find our highest y value. That's up here. I follow that line across. It hits right at the 40. Now, does it actually touch the 4? Yes, it does. So that one gets a square bracket. Does it actually hit the 40? Yes, it does. That one also gets the square bracket. So this time it means that 4 is less than or equal to y, which is less than or equal to 40. Traditionally, teachers tell you that if there's a break in the graph, if there's a hole in the graph, a place where it doesn't meet, that it is discrete. I would say this graph is discrete because of the hole in it. Your job? You need to finish graph B and graph D. You can back up this video and watch me do the first two again if you need help. Alright, looking at the back side of this worksheet, you have a couple of problems to do. Mr. Davidson works out at the local gym. The doctor told him to monitor his heart rate during his workout. When he begins his workout, his resting heart rate is 70 beats per minute. The doctor told him that his heart rate during his workout should never exceed 190% of his resting heart rate. Identify the independent and dependent values. If he works out for 45 minutes, what is a reasonable domain and range for this situation? So remember, you need to be able to identify independent versus dependent. Remember, the dependent variable is the one that depends upon the other one. Look at this and see which piece of information depends on another piece of information. That's the one that's your dependent. The one that it depends upon is your independent variable. Now, think about your domain and range. Remember that your domain goes with your x values. Where do your x values live? Your range is asking you about your y values. Where do your y values live? Moving on to number 3, classifying data as discrete or continuous. Remember, discrete means that there's a hole or a break or a jump in the graph. Continuous means that there aren't any holes or breaks or jump in the graph. So I want you to think about what the graphs of each of these 4 situations would look like, and then you'll know whether that data should be discrete or continuous. Would the graph look like a nice smooth line or curve, or would it be points or pieces of lines, line segments, put together on a graph? Write a situation to represent a discrete relation. Remember, that's something that if you were to graph it, would have a break or a jump or a hole in the graph. Think about what could cause you to put a break or a jump or a hole in a graph. Write a situation to represent a continuous relation. Think about something that if you were to graph it, would graph in a nice, smooth, continuous, solid line or curve. That's a good situation. All right. Find the specific domain for the given range. Well, remember, range are the y values. So really what I'm asking you to do is take each of these values and plug it in for the y value here and find out what the x should be. So you're going to have to do some algebra. I'll help you start the first one. So -7 is one of your values, and it's the range. That means it's the y. So let's plug in -7, and I'm going to set it equal to -2x minus 3. Now this is a nice straightforward algebra problem. First of all, how do I get rid of a -3? That's right, I add it to both sides. Remember, whatever I do to one side, I do to the other. -7 plus 3. The signs are different, so in my head I subtract the values, which is 4, but I take the sign of the larger number, so it's really -4. Equals, and now I need to bring down the -2x. Now what do I do to get the x totally alone? I divide both sides by -2. A negative divided by a negative is a positive, so that's +2 equal to x. Now see how my range has been given in this set notation? when I give back my answer for my domain, I want to use the same notation, and I want to put the answers in order as they're asked for. So since the first one had a value of 2, I'm going to put a 2 and a comma, and now you need to do the same process, plugging in a -3 instead of a -7. Then you need to plug in a -1 instead of the -7. Then you need to plug in the +1 instead of the -7. And finally plug in the 3 instead of the -7, solving for x using the same steps each time. When you do the next problem, you're going to plug it into the other equation, but also for the y. Remember, range represents the y. I'll do the first one with you. So this time we have 5x plus 4y equals 35. So 5x plus 4 times my y value. Well, the first y value, the first range you're given is -5. So plug in the -5, and that's supposed to equal 35. Okay, now we're going to do the algebra. We need to simplify the parentheses here. So it's 5x, positive 4 multiplied by -5. A positive times a negative is a negative. 4 times 5 is 20, equals 35. Now it's a nice two-step equation. How do I get rid of a -20? Well, that's right, I add 20. So 5x is equal to 55. Now how do I get the x totally alone? I'm going to divide both sides by 5. So x is 11. Just like on this problem where I said you needed to use the same notation, we're going to do the same thing here. Start my set notation. -5 had the answer of 11, so I put an 11. I'm going to put a comma, and now I have to do the next 4 problems where I'm going to replace the -5 first with the -1. Then I'm going to replace the -5 with the 0. Then I'm going to replace the -5 with a 5. And then I'm going to replace the -5 with a 10. But I'll follow the same general order of the steps to find out my x value each time. The only difference between problem number 6 and problem number 7 is now you're given the domain. Remember that domain is a fancy word for the x values. So this time you're going to plug in each of these values for your x, and this time you're going to solve for y. So when you give your answer, remember you're going to use similar notation, except you're giving the range, so you're going to start each one with the capital R. But you're going to do the same type of algebra problems as you see here. So the first one will have y equals -4 multiplied by -4 minus 6. So y equals, a negative times a negative is a positive. 4 times 4 is 16. Bring down the -6. And finally, we find out that your first answer is that the y equals 10. So in this first set, the first value for the range is 10. Put a comma. Do it again for the -2, the 0, the 2, and the 4. Then you need to do part B. Same idea. This time you are solving for the y. So this one will be 4 times, your first x value is -9. You need the plus 3y equals 36. 4 times -9. A positive times negative is a negative. 4 times 9 is 36. Bring down the plus 3y and the equals 36. Now, how do you get rid of a -36? You add 36. So 3y is equal. So we added 36 to each side. We found out that 3y was equal to 72. Our last step is that we will divide both sides by 3. Let's see, 72 divided by 3. 3 goes into 7 twice, which is 6, leaving 1. Bring down the 2. 3 goes into 12 4 times, which is an exact, so that's 24. So apparently y equals 24. So the first number in my answer set is 24, and now I will do the same set of problems for -3, then for 0, then for 6, and then for 9. Good luck, and remember you can rewind the video and watch me do any of these problems again step by step.